The star creepy-crawly Jew, a red, exceptionally monstrous beast found in the magnificent group of Orion, has long enchanted stargazers and cosmologists alike due to its sheer size and splendor. If bug juice were set where our sun is, it would stretch out to the orbit of Jupiter, affirming its giant size. Despite being situated around 642 light-years from Earth, its immense size makes it potentially one of the brightest stars visible to the naked eye. Recently, Betelgeuse has shown peculiar behavior, such as surprising dimming and brightening cycles, which many researchers believe signal that the star is approaching the end of its life. The famous physicist Brian Cox recently made a significant statement that Betelgeuse is on the edge of a staggering explosion expected to occur within the next 14 days. This event, known as a supernova, will mark the end of Betelgeuse's life, but will provide a unique opportunity for researchers to study one of the most fascinating and powerful phenomena known to the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been on the astronomical radar for decades, but its recent unusual fluctuations in brightness have sparked speculation that it is preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under its gravity, triggering a massive explosion that releases vast amounts of energy, radiation, and enormous material into space. Betelgeuse's impending explosion is expected to be a Type II supernova, a specific kind of stellar explosion that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shockwave that destroys the star. The explosion will be so bright that it may be visible from Earth without telescopes, perhaps even outshining the moon in the night sky for weeks or months. While such an event would typically be catastrophic if it occurred near Earth, Betelgeuse's distance of around 642 light-years means that, although the explosion will be visible and dramatic, it will not pose any threat to life on our planet. Nonetheless, the event promises to reshape our understanding of supernovae and cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in seconds than the sun will emit throughout its entire lifetime. Betelgeuse's explosion will not only be an astonishing cosmic display, but also a significant moment for science. Researchers are eager to observe this fascinating event from its earliest moments, using a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope (JWST), to capture as much data as possible. When Betelgeuse explodes, it will emit a wide range of radiation, from visible light to gamma rays. One of the most crucial aspects of the supernova will be the surge of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion due to their ability to pass through nearly everything without being affected. Observatories like Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in monitoring Betelgeuse's final moments. The explosion will also offer essential insights into the creation of heavy elements. When stars explode, they produce and disperse elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will offer researchers a clearer view of this element formation process, which is vital for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova isn't expected to have harmful effects on Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could result in more intense auroras, expanding the regions where the northern and southern lights are visible. While these cosmic rays could affect satellite communications and some technologies on Earth, the disruptions are expected to be minor and temporary. Perhaps one of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, bug juice is expected to be the brightest object in the night sky, possibly even visible during the daytime. This spectacle will captivate not only the scientific community, but also amateur stargazers and the general public, sparking renewed interest in space science and the universe. Scientists have long speculated about Betelgeuse's demise, but Brian Cox's recent statement adds urgency. Observatories worldwide are preparing to monitor every phase of the supernova, and the data collected will be crucial, potentially transforming our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such an explosion travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clearer understanding of the universe's scale. The event will also offer a once-in-a-lifetime chance to study dark matter and its potential impact on the universe's structure. Dark matter, the mysterious substance that makes up around 85% of the universe's mass, doesn't emit or absorb light, making it challenging to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about dark matter's role in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycles of stars, particularly how massive stars contribute to the formation of the elements essential for life. Supernovae are the key cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even living beings. The social significance of Betelgeuse's explosion is also considerable. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most visible stars in the Orion constellation will prompt philosophical reflection on the transient nature of the universe. In some cultures, such celestial events have been interpreted as omens or signs of great change. Betelgeuse's explosion might inspire a mix of awe, wonder, and contemplation as people from all walks of life witness the death of a star. This grand event is likely to reignite interest in space exploration and astronomy, drawing more people into the pursuit of knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to observe and record the supernova. This democratization of science will unite people across the globe, all watching and documenting the same cosmic phenomenon from their unique vantage points. Betelgeuse's explosion is not just a spectacular cosmic event, but also a stepping stone for future exploration. The data gathered from the supernova will inform how we study other stars, especially as humanity ventures further into space with missions to other planets and star systems. Understanding the life cycles of stars and the properties of supernovae is crucial as humanity seeks to extend its presence in the solar system and beyond. Additionally, the explosion will renew interest in the search for extraterrestrial life. Supernovae are essential for spreading the building blocks of life, such as carbon and oxygen, across the universe. By studying Betelgeuse's explosion, scientists can better understand how these elements might spread to other planetary systems and possibly spark life elsewhere in the universe. The looming blast of Betelgeuse is set to be one of the most significant cosmic events in recent memory. Its supernova will provide a wealth of scientific data, enhance our understanding of the universe, and undoubtedly captivate people worldwide. Betelgeuse's death will mark the end of a giant star, but it will also represent the ongoing cycle of creation and destruction that governs the universe, reminding us that from death, new stars, planets, and even life itself can emerge. As we prepare for this historic event, the world will eagerly watch the night sky, anticipating the moment when one of the universe's most powerful forces explodes into view. For both experts and stargazers alike, Betelgeuse's final journey will be extraordinary. As Betelgeuse approaches the last phase of its life, one of the more speculative yet fascinating possibilities linked to its impending explosion is its potential to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These enigmatic forces are believed to account for most of the universe's mass and energy, yet they remain poorly understood. Some speculate that supernovae like the one expected from Betelgeuse could hold the key to unlocking some of these mysteries. Supernovae release enormous amounts of energy and radiation, and some experts believe these powerful forces might interact with dark matter in ways we can observe and study. One intriguing hypothesis is that dark matter exists as weakly interacting massive particles, WIMPs. If WIMPs exist, their interaction with the energy produced by Betelgeuse's supernova could provide detectable evidence of dark matter. Observing how this energy disperses through the interstellar medium could yield critical data on how dark matter behaves and influences cosmic structures. Similarly, the supernova might also shed light on dark energy, the force driving the accelerated expansion of the universe. While direct observation of dark energy remains elusive, studying how light and radiation from Betelgeuse's explosion move through space could offer indirect clues about its effects on the large-scale structure of the universe. Betelgeuse's supernova will also enhance our understanding of the cosmic web, the vast interconnected structure of galaxies, gas, and dark matter that forms the universe's framework. As light from the explosion travels through this web, astronomers will be able to trace its path and map the universe's structure more precisely. The scientific and philosophical implications of Betelgeuse's explosion are immense. It will be a rare and awe-inspiring reminder of the universe's dynamic nature, where creation and destruction are in constant balance. As humanity watches the night sky, we will witness not just the end of a star but a cosmic rebirth, where the elements forged in Betelgeuse's core will be scattered across space, potentially forming new stars, planets, and perhaps even life in the distant future.